Alright, so this is the point in this course that I say that it's time for a little math review. It's time to remember some things that I know for sure you've learned in the past, but maybe some of you have conveniently forgotten over the course of your mathematical education. This is something that usually comes up in either Algebra 2 or in pre-calculus. I know for sure you've seen this in Algebra 2. I know it comes up in great detail in calculus. And it is also very important here in physics when we start working with vectors. And that's right triangle trigonometry. And there are four equations that you should know by heart. And you should have known these equations by heart when you came into class this year. And those four equations are right here. Pythagorean's theorem, c squared equals a squared plus b squared. So the sum of the squares of the two sides equals the hypotenuse squared. And the definitions of sine, cosine, and tangent. Sine equals opposite over a hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Of course, here I have them in terms of my triangle here, where we have A, B, and C. B is the opposite side to the angle, A is the adjacent side, and C is the hypotenuse. So Pythagorean's theorem and SOHCAHTOA are the way that I remember these four equations that are really quite important when we start looking at vectors. Let's look at a couple of example problems that we can use right triangle trigonometry to figure out, just kind of practicing with triangles. Let's say that the adjacent side A was 5 units long and C was 9 units long. Let's find both B and theta. Now I can use Pythagorean's theorem to find B. C squared equals A squared plus B squared. Solve it for B squared, and then square root both sides. The one thing to remember here is that the square root of C squared minus A squared does not equal C minus A. So what we'd have is the square root of 9 squared minus 5 squared, or the square root of 56. So B is basically 7.48 units long. If we wanted to figure out the angle theta, well, I know cosine of theta is equal to adjacent over hypotenuse, A over C. I have both A over C. I can do a function called inverse cosine, which reverses cosine, basically says what angle relates to this cosine. And if we have inverse cosine A over C, so inverse cosine of 5 over 9, then you should get 56.2 degrees. Now the one thing to watch out for with cosine, sine, and tangent is you need to know what units your calculator is set up in. And you use degrees almost always to talk about an angle. In math, you use radians a lot to talk about an angle. The reason why we use degrees in physics is it's a much more precise measure for an angle versus radians, which actually relate a lot better to number of times around a circle and help you relate angle, arc length, and radius of a circle. Let's do another quick problem. Let's say we knew the angle was 40 degrees and we know B is 6. Let's find A and C. So basically we're reversing the problem. I can use sine of theta equals B over C. So if I multiply this out, C times sine of theta, I'm trying to solve for C, so I got to multiply C over to the other side to solve for it, equals B. And divide both sides by the sine of theta. C is equal to B over sine of theta. And so C is equal to 6 divided by the sine of 40 degrees, and that's 9.33. We can do the same thing for A and B, that tangent of theta is B over A. Multiply the A over to the other side, divide by tangent of theta, and we get 7.15 units as A. Now it's worth pointing out I could conceivably use Pythagorean's theorem to find A as well at this point. I usually would use the equation that has variables that I knew from the beginning of the problem. That's kind of a quick overview of right